So for a series circuit, this is what we're given. We should do what we can. You kind of start somewhere and you keep going. Equivalent resistance is always a good place to go. And so if this is a series circuit, equivalent resistance is always going to be just the sum of the resistors. In this case, it's going to be 10 plus 15, and that will give us 25 ohms. Okay. So there's 25 ohms. Their next best bet is we really don't have anything here, right? We don't have anything in the R1, R2 columns. Nothing there. So we can't, and we know that it's not going to be the same voltage across each resistor because it's a series circuit. Our voltage will drop at every resistor. So then we can figure out instead, we will use Ohm's law to figure out the total current for the system. So that'll be 2. So current is equal to voltage over resistance. In this case, it's 9 volts over 25 ohms. That will give us 0.36 amps. Now, because it is a series circuit, we know that it has the same current everywhere along the way. So step 3 is to recognize that fact and give us these two currents. Now that we have those two currents, we could go ahead and we don't really need to use the loop rule or the junction rule now. This one's one of the ones that's easier just to use Ohm's law. So for step 4, we're going to figure out the resistance for resistor 1. So the voltage across resistor 1 is going to be the current times the resistor 1. So it's 0.36 times 10. Giving us 3.6 volts. For the next one, we're going to do the same thing, but we're going to use the information for resistor 2. So that's V2 is equal to the current times the resistance across that resistor. 0.36 times 15. And that is... wrong one. That is 5.4 volts. Now note, guys, that if I were to add this one and this one, if I add them together, it equals 9, which makes sense because the voltage voltage decreases around. Okay, once you've got that, then it just becomes power equals current times voltage. So we'll do the power across 1. Current times the voltage 1. So we've got 0.36 times 3.6. And that gives us 1.3 watts. That was what, step 6? Step 7, we'll do the same thing. .36 times 5.4. That will give us 1.94. We can do the same thing for the total power. So P total is equal to IV total, 0.36 times 9 volts. That'll give you 3.24. Now, P, we say total of something, right? That means add it up. So if you note that write this in here. If you were to add up the power across resistor 1 and the power across resistor 2, 1.3 plus 1.94, that'll give you 3.24. Okay? So you also could have done P P total is equal to P1 plus P2. It doesn't matter. The only benefit would be sometimes if you got easy numbers, rather than multiply, just go, hey, 10 plus 2 is 12. That's about it. All right, so while you guys are finishing writing this, I'm going to fill in the step numbers. So that when somebody comes back, they can go ahead and follow their own work. That's 2 and 3. Okay. The next thing, we're going to do the same thing, but we're going to do it with a parallel circuit. Okay, 10 more seconds. Are there any questions, any places where it was just going too fast? You're like, I don't know what happened. What did you do? Makes perfect sense when I do it, doesn't it? Somehow it changes to a completely different language when you're looking at it by yourself. It happens to all of us, guys. Okay, I'm going to turn the page.